time for some e-learning with Miss Atkin. E-learning with Miss Atkin. E-learning with the puppy. E-learning with Miss Atkin. Yeah. What's up, scholars? Today we're talking about the dog and the cat. Now that that's settled, that's Max in the back. That was Beanbutt running around. Today we're really talking about section 9.6, solving a right triangle. Now what does that mean? It's going to mean finding all the side lengths and all the angles in the triangle. Solving means, in this case, finding all angle measures and side lengths. Cool. So there's a couple tools we're going to use here to do this. We'll be using our Pythagorean theorem. So that'll be a little review. And that'll help us find some side lengths. And then we're going to use the inverse trig functions. Which are going to be inverse sine, inverse cosine, and inverse tangent. These are sometimes referred to as arcsine, arccos, arcsine, arccos, and arctangent. Okay, those are the inverse functions. These are going to be our two tools used to find all the angles and all of the side lengths of a right triangle. So we're going to jump right in with an example. Here's our example. Solve the right triangle. Here's our right triangle. We have a side length that's 5 units long, a hypotenuse across from the right angle that's 13 units long. So to solve this right triangle, we need to find all of the side lengths and all of the angles in this triangle. We're going to find the lengths of the 3 sides and the measures of the 3 angles. So we already know a couple of these things. We already know that AB is 13. We already know that BC is 5. We can use our Pythagorean theorem to figure out the third side. Right? Pythagorean theorem says a squared plus b squared equals c squared. A squared plus b squared equals c squared. We know our c is our cross from our right angle, so that's 13. So we'll say 5 squared plus b squared is 13 squared. Again, the b this time is across from angle B. That'll be the side length, which will be the same as side AC. Right, AC will be the B we're solving for here. So 5 squared is 25 plus B squared equals 13 squared is 169. Subtract 25 on both sides. And we get B squared equals 144. And we square root both sides because those are inverse operations. That's what we do to get B by itself when B is squared. The inverse operation that gets B by itself is the square root. Square root both sides, and we get, of course, B equals 12, which means AC equals 12. And some of you may have recognized this as a Pythagorean triple, a 5, 12, 13 triangle. Right? Pretty cool. All right, so now to find these angle measures. So we're going to use a similar idea here, where we had b squared equaled 144, and then we square rooted both sides to get that b by itself. We're going to use these inverse operations of our trig functions to figure out these angle measures. So, for example, we have, if we look at angle A, we know the sine of angle A is the opposite side over the hypotenuse. Let me write that down. The sine of angle A is, we'll just write the whole thing, opposite over hypotenuse, which in this case, sine of angle A is the opposite side is 5 over the hypotenuse is 13. So we know the sine of angle A is that decimal. Ooh, 5 divided by 13. Let's put 4 digits there. 0.3846. But I really want to know the measure of angle A, not the sine of angle A. So what we're going to do, again, just like here, we use the inverse operation of squaring, which was square root. The inverse operation of sine is going to be the inverse sine. So we're going to take the inverse sine of both sides. Oops. The inverse sine of both sides. Okay, and when we do that, the inverse sine of sine, right? The inverse sine of sine will get A all by itself, which will mean the measure of. And then we just use our calculator to find the inverse sine of that decimal. Let me bring up my calculator here. Show you a couple ways to do this. You're going to make sure we're in degrees. Right? Turn my light on. Oh, no, that's a terrible idea. Terrible, terrible, terrible idea. Sorry about that. Okay, in degrees, I want the inverse sine. So I'm going to go over. See, it says INV, inverse, up there at the top. So I'm looking for the inverse functions, the inverse sine. I want the inverse sine of 0.3846. So that means the measure of angle A is 22.6 degrees. 22.6 degrees. 22.6 degrees. Okay, cool. If you need additional help on how to figure out how to find the sine inverse function, you can also go ask the internet for a calculator, because maybe your phone calculator doesn't have that and you need to figure out that function. So we'll look up inverse sine, inverse trig calculator. How's that? Inverse trig calculator. Found this calculator soup one. And we click and it loads, and that's all great. So again, this is where I was saying sometimes it's called arcsine, arccos, arctan. Don't worry about the other 3 down here. You'll get to those in pre-calc, I believe. So this will be our inverse sine, our arc sine. We're finding the arc sine of 0.3846. And we calculate here. And it gives us that 22.6 degrees we were looking for. All right, so again, this is the calculator soup option. Great. So we found the measure of angle A, it was 22.6 degrees. We know the measure of angle C is 90 degrees. So now you actually have 2 options for finding the measure of angle B. You know that since this is a triangle, all of these will add up to how much? 360, exactly. Haha, just kidding, 180. 180, exactly. So we could say 90 plus measure of angle B plus 22.6 equals 180 and solve that. So we get the measure of angle B plus 90 plus 22.6 is, what is it? I'm having too much of a hard time here. 22.6 plus 90. Good. 112.6 equals 180. You know, it's fine, use your calculator. 180 minus 0.6. You know, or I'm just struggling so hard right now. 180 minus 112.6. 67.4 degrees. The measure of angle B will equal 67.4 degrees. That's one way to do it. I'm going to show you one other way to do it so we can practice using another inverse trig function. Okay, so the other angle that we need is angle B, which we know is going to be 67.4. Okay, I'm going to slide my face. No, we're just going to go like that. Great. Wonderful. Cool. There goes my head. Okay. So we're looking at angle B. We know all of the sides of the triangle. We know side B is 12, or we could continue using these original sides. So I could use the side that's right next to B, which is called the adjacent side, and the hypotenuse side. Right? I know the adjacent side is 5, the hypotenuse is 13. The trig ratio that uses adjacent and hypotenuse is cosine. So we know that the cosine of angle B is the adjacent over the hypotenuse. So the cosine of B is 5 over 13. So the cosine of B is that same decimal. And then we take the inverse cosine of both sides to get B by itself. And then we go back to our calculator. This is going to get B by itself. So we're going to find the inverse cosine of 0.3846. Let's go back to this calculator. Now I want the inverse cosine of 0.8. Oh, I thought maybe it'd keep it for me. That would have been nice. 3846. Great. Inverse cosine 4 degrees. Great. 67.4 degrees. 67.4 degrees. 67.4 degrees. Fabulous. So we just solved the triangle. Oh yeah. So good. Doing great. Like I knew you would. Okay, so that was an example where we started off with two sides and obviously one angle because we knew it was a right triangle. Let's do one more example where we start off with two angles and one side. Alright, so here's our second example. We're going to solve the right triangle, round our answers to the nearest hundredth. We have this right triangle here, triangle XYZ. It's a right triangle because it's got that little box. One of the angles is 65 degrees, and we know the hypotenuse is 20, so let's solve it up. Let's find all the side lengths. And all the angle measures. Cool. Now let's do everything the fast way, right? Because we are math magicians, let's do everything the fast way. Write down what we know so far. XZ is 20. Angle Y is the 90-degree angle. Angle X is 65 degrees. So angle Z will be whatever we need to get these three to add up to 180. So 180 minus 90 minus 65 is going to be 35 degrees. Cool. These should all add up to 90. Great. Now, we got to solve for these side lengths. So we're going to need to use our inverse trig functions. We just got to figure out which trig function we want to use. We know the hypotenuse, so we'll have to use that when we solve. Let's say we can actually pick any of the angles we want for reference, since we know all three of them. We're never going to use the right angle, but we could pick either X or Z. So let's pick angle X. And then let's say we're going to solve for A first. So we're going to use the opposite side from angle X and the hypotenuse here and this 65-degree angle. So we're going to say the sine of the measure of angle X is equal to the opposite over the hypotenuse. Write that down. Sine of X equals opposite over hypotenuse. We know X is 65 degrees. The opposite side is what we are solving for, and the hypotenuse is 20. Okay? So then we're going to multiply 20 on both sides. So we'll have 20 times the sine of 65 degrees equals A. Punch that into our calculator here. What, I should still have mine. That's not a calculator. That's a calculator. Great. So we want 20 times the regular sine of 65 degrees is 18 point, we said the nearest hundredth, so 1, 3 is A. Great. A is YZ. YZ is 18.13. Cool. Now, you could use the Pythagorean theorem to figure out the last side. So let's go ahead and do that. All right, we're saying A squared plus B squared equals C squared. We now know A is 18.13, so we have 18.13 plus B squared equals, oops, that's squared, right? 20 squared. 18.13 is squared is 328.6969 plus B squared equals 20 squared is 400. So 400 minus 328.6969 equals B squared is 71.3031. Now we're going to square root both sides. So B will equal 8.44 if we round to the nearest hundredth. 8.44. So there is our solved triangle. Now we could also have used cosine of 65 would equal B over 20, right? Because cosine of X is the adjacent side over the hypotenuse. Multiply by 20 on both sides. 20 times the cosine of 65 would be B. If we did that, we'd have 20 times the cosine of 65 would be B, which gives us 8.45 if we round to the nearest hundredth. This is actually slightly more accurate, right? Because we rounded over here. But I'll give it to you. Cool. All right, beautiful people. That's it. That's solving right triangles. Bunch of geniuses. You guys are going to get it. Because you're a bunch of geniuses. I love you. Come hang out with me in office hours. And I'll see you next time.